Hey everybody, so we are now going to be talking about the triangle proportionality theorem. This theorem is very similar to what we talked about with the parallel lines and triangles. And that's actually kind of where that theorem comes from, is this one. And you'll see what I'm talking about once you see the picture. All right? Okay, so if you've got the triangle proportionality theorem, oops. Okay, so if a line is parallel to one side of a triangle and it intersects the other two sides, then it divides the sides into segments of proportional lengths. This is kind of like that triangle angle bisector theorem, but now working with sides and no special segment. All they need to be is a line that's parallel and intersecting. So pretty much, if DE is parallel to AC, then we can state that BD and DA are going to be proportional, and so are BE and EC. And I like to use this kind of like our triangle bisector theorem, angle bisector theorem, sorry. I like to use that middle parallel line as kind of my, hey, this is my fraction line. It's splitting it up. So I've got BD over DA and BE over EC. Now the converse also holds true. So what that means is that if these four sides are proportional, then we can state that DE is parallel to AC. All right, so it can work both ways, which is really nice on this one. So we're going to do an example of just the theorem first, and then you're going to try to solve for x on some of them. Okay, so this first one, notice I'm going to use this to make my line, this parallel line. I don't know what that tiny part is, but I can figure out, since this entire part right here is 55, and this big part is 45, I know that this is 10. So I'm going to do x over 36 is equal to 10 over 45. And now that it's set up this way, I can use this really nicely and simplify it. Okay, because both of these are divisible by 5, I can do 2 over 9 here. All right, now there was another way to go ahead and set up this proportion had you done 10 over x, so pretty much doing it one side of the triangle, 10 over x, 45 over 36. And you can do it that way as well. But you do what works best for you. We're going to go ahead and cross multiply. And no matter if you simplify or not, you're still going to get the same answer. So we get 9x is equal to 36 times 2, which is 72. Divide both sides by 9, and you get x is equal to 8. It's really that easy. So what I want you to do now is I want you to set up example 1 and check your answer against mine. All right, here is how I set it up. I use that middle parallel line to help me split this up. And I got x over 15 is equal to 14 over 12. And then I simplified. And you should have gotten a fraction, a decimal of 17.5. All right. Number 2 on this one, we're going to work on this one together. And what's going to end up happening is that you're going to have to distribute. So let's use that parallel line to split it up. And we get 30 over x plus 7 is equal to 25 over 15. All right, then what I did is I am going to go ahead and simplify. And I get 5 over 3. And then when I cross multiply, I get nicer numbers to work with. So I get 5 times x plus 7 is equal to 30 times 3, which is 90. Distribute your 5, you get 5x plus 35 is equal to 90. Then you get 5x is equal to, what was it, 55, and you get x is equal to 11. Now remember, this is just a theorem. You can also apply its converse by figuring out, hey, are these two lines parallel? So is MN parallel to JK? I'm sorry, to JL. So we are going to, in order to figure this out, we're going to assume that MN and JL are parallel. So we can set up our proportion. And we're going to do 11 over 15.4 is maybe equal to, and that's why we put that question mark over it, 10 over 14. All right, so we're going to do 11 times 14, and that gets me 154. And then I'm going to do 10 times 15.4, which also got me 154. And since both of these are equal, then yes, MN is parallel to JL. Which means if they were not equal to each other, they would not be parallel. So I want you to try number 4. Pause the video and then check yours with mine. All right, so we are assuming that MN and JL are parallel. So we're going to do 18. Let me switch to a not as mean color. And we're going to do 18 over 5 is equal to 15 over 4. Maybe. Okay, cross multiply, and 5 times 15 gets you 75. And 18 times 4 gets you 72. Since these two are not equal to each other, we're going to say no, MN is not parallel to JL. And that's just me using shorthand. You can go ahead and not use the symbols and just use the words. All right, so that's part of it. The next part of it is going to be this one. This is the one that I was referencing earlier, the parallel lines, and we had congruent parts last time. Now it's going to be proportional parts. So if 3 or more parallel lines intersect 2 transversals, then they cut off the transversals proportionally. So we had it that these two were equal and these two were equal, right? They were all split up at equal parts. Now we're working with it where they are proportionally split off. If these 3 or more lines are parallel to each other, then we can state that this part right here is proportional to that CE. And same thing on the other side with BD being proportional to DF. And I like to, again, use this right here as my fraction line. You can also do it on opposite sides where you're skipping, and you can do AC over BD is equal to CE over DF. Whatever works for you in that manner. All right, so I'm going to help set up number 5 and 6, and then I want you to check your answers with me. All right, so for number 5, all we're going to do is we've got 45 over 18 is equal to 52 over x. And then you're going to cross multiply and solve. And on this one, on number 6, you're going to figure out this tiny little part is going to be 14 because that's 32 minus 18. So I want you to go ahead and set your proportions up, cross multiply and solve, and then check your answers back with me. So pause the video. Should have gotten this for number 5. Number 6 worked out nicely because you could have simplified. I set it up as 18 over 14 is equal to 27 over x, and I simplified them both by 2. So I got x is equal to 21. All right, number 7, I am going to help you get started with it. It's the same concept, but this time you're just going to be double distribution. Okay, so you've got 2x plus 2 over 21 is equal to x plus 3 over 12. So we can do it this way, one over the other, up and down, up and down. Or you can also do it where you're just going straight across. So I can do 21 over 12 is equal to 2x plus 2 over x plus 3. And that one, I like that one better because I can simplify both of these by dividing them by 3, and that's going to help me out. Let me see. Hold on. And I think, oh, yeah, there we go. 7 over 4, cross multiply, and you get 7 times the x plus 3 is equal to 4 times 2x plus 2. Solve for x by distributing, combining like terms, yada, yada, yada. Pause the video and then check your answer with mine. All right, and you should have gotten x is equal to 13. Thanks for watching.